So at this point, we know how to solve quadratics by taking a square root, and we also know that we can solve quadratics by finding their roots or zeros. So let's take a look at how we can solve quadratics by factoring. So if we want to solve a quadratic by factoring, it's all based on the idea that if we have two things being multiplied together. Okay, so if I'm multiplying two things and they have a solution of 0, then either A is going to have to equal 0 or B is going to have to equal 0. And this is just based on the fact that 0 times a number equals 0. Right? With other numbers, we have choices of how the order can be changed or negative or positives that come into play. 0 is the unique number that when we multiply it by something else, it always gives us an output of 0. We can then use that for any situation where we have things being multiplied together. So if I have something like x plus 5 times x minus 4 equals 0, we really have two things that are being multiplied here, right? We have our first factor, which is going to be x plus 5, and our second factor, which is going to be x minus 4, which means according to our rule above, if this equals 0, then either x plus 5 is going to have to equal 0, or x minus 4 is going to have to equal 0. Okay, so I'm just taking the different things that are being multiplied together, and I'm setting them each individually equal to 0. So if I solve this, right, this is just solving one-step equations. Then I'll get solutions of x equals -5 or x equals 4. Right, I have two possible answers, which is the same thing we've seen when we're solving by taking a square root or when we're solving by finding the roots or zeros. Now, unfortunately, every problem won't already be set up in this format for us, which means we might have to do a little bit of work to get there. So maybe we have a problem that says x squared plus 7x plus 12 equals 0. Okay, again, it's all based on the fact that we need the problem to equal 0. So if we want to solve by factoring, the first thing that we need to know to be true is that it has to equal 0. Okay, so if it doesn't equal 0, then we are going to make it equal 0. Okay, by simply doing some basic addition or subtraction and moving some things around. Okay, once we have it set equal to 0, we are going to ignore the part that says equals 0, and we're just going to focus on the other part of the equation. Okay, so I'm going to ignore the equals 0, and I'm going to factor what's left. Okay, so I'm going to factor x squared plus 7x plus 12 equals 0. Okay, now if I look at this piece right here, if I'm focusing right here, we should remember from our factoring rules that this says we want to factor this as a trinomial. So if you forget how to factor, you're going to have to go back and look at your factoring rules, okay? But a times c is 12. So we need to list our multiples of 12, right? And we want to find a set that will add up to b, in this case 7. So we want to pick 3 and 4. Right, and in this trinomial, because a equals 1, we can use our shortcut, and we can take this right to x plus 3 times x plus 4. Okay, so all that factoring did was give me another way for me to write the x squared plus 7x plus 12. So instead of writing the x squared plus 7x plus 12 here, I can now replace it with this x plus 3 times x plus 4. Okay, so I have a new equation that says the exact same thing. It's equivalent. It just looks different because it's in its factored form. Right? So I now have x plus 3 times x plus 4 equals 0. And if we go back up to our rules above, again, that tells us that now we can set each of these equal to 0. And that's something we know how to solve. And so we will get x equals -3 or x equals -4. Now the key to being able to do this is that A, we have to get it set equal to 0, but also B, that we know how to factor, which means you should be able to take any problem that's given to you, okay, at least if it's able to be factored, and you're just going to have to remember your factoring rules. So if we look at this problem, right, we already have the first step taken care of. It is set equal to 0, so that's done. Our second step is then to factor it. So we would need to recognize, looking at this problem, that we can factor out a GCF. Okay, so again, if you forget how to factor, so if you forgot how to factor out a GCF, you need to go back and look at factoring and factoring out GCS. Okay, we have two things being multiplied together, so we have a 3x times a 2x plus 1. So I can set the 3x equal to 0, and I can set the 2x plus 1 equal to 0. Those can both be solved. Again, this is just our basic solving equation rules. If you're not sure how to solve these, then you would need to go back and look at how we solve equations. Okay, we'll get answers of x equals 0 and x equals -1/2. So I'm looking at two different problems where we chose to solve by factoring, but keep in mind that this is a GCF, this is a trinomial, right? We also might have to factor trinomials that aren't shortcuts, or problems that are grouping, or all different types of factoring could be involved. It's not just limited to those two types. So let's take a look at one more problem where we have to do a little bit of additional work. So maybe we have something that says 3x squared minus 5x equals 8. Okay, so if we look at this problem, okay, here we do not have it set equal to 0. So we're missing the first key part, which says it has to equal 0. Okay, since this one does not equal 0, we need to do some rearranging or moving things around to make it equal 0. Okay, so in this case, I can move my positive 8 by subtracting 8. And whatever I do to one side, I have to do to the other. Now, you will have to then decide when you look at a problem if any of these terms can be combined. Okay, in this situation, they can't be. And you'll also want to make sure that when you write it down as 3 different pieces, that you're writing it in the correct trinomial order, which means we want the ax squared first, the bx second, and the c third. Then once you're here, you do have it set equal to 0, and now we're just back to factoring, right? So in this case, trinomial, 3 times -8 gives us a -24. We'll list our multiples. Okay, we know that we want our larger number to be negative. So we'll choose 3 and -8. We cannot use the shortcut here. So this one we would need to rewrite and factor by grouping. So if you forget how to factor by grouping, you might need to go back and figure out how to do that. So this factors into a 3x minus 8 and an x plus 1. Okay, so we can now set each of those equal to 0. So we'll say 3x minus 8 equals 0. And x plus 1 equals 0. These we can solve just like this one is a 2-step equation. Our other one's going to be a 1-step. Fraction answers are fine. Just make sure they're reduced. And so we'll get answers of x equals 8/3 and x equals -1.